Hello 8th graders and welcome to Math Weekly number 8, where our focus skill will be solving equations with squares, square roots, cubes, and cubed roots. Let's begin with some equations basics. When solving an equation, this phrase can help you understand what to do. Use inverse operations to isolate the variable. Inverse operations means to do the opposite operation in order to eliminate that operation. Isolate the variable means to get the variable all alone, which is the goal. When the variable is all alone, you will know the value of the variable. Today's focus is going to be on two pairs of inverse operations, squares and square roots. So if an equation has a square, you will need to use a square root in order to find the solution. The opposite is true as well. If the equation has a square root, you will need to square the equation in order to find the solution. And our second pair are cubes and cube roots. If our equation has a cube, we will need to use a cube root in order to isolate the variable. If it has a cube root, we will need to use a cube in order to find that solution. So let's look at one example of each type. In this first example, we have an equation with a square. I know this because the variable is being squared. The opposite of a square is a square root. So if I square root this side, the square and the square root will eliminate because they're opposite operations. It's kind of like if you add 2 and then you take away 2, they undo each other. So what's left is x. Now, a rule of equations is if you want to keep the two sides equal to each other, if you square root one side, you must square root the other. So x is equal to the square root of 25. Now, most times when we square root 25, we know that the answer is 5, which means positive 5. But when an equation with a square has been square rooted and it's out of context, meaning it's not part of a real world situation, there is more than one answer. Positive 5 times positive 5 does make 25, but so does negative 5. Negative 5 times negative 5 makes a positive 25. So every equation with a square has two answers, one that's positive and one that's negative. So x equals plus or minus 5. Let's go to an equation with a square root. So the square root of x. The square root of x is being square rooted. The opposite of a square root is to square. So I'm going to square this whole side. When I square this whole side, the square and the square root eliminate each other since they're inverse operations, and I'm left with x. But the rule of equations is whatever I do to one side, I need to do to the other. So I squared this side, so I need to square this side. So x is equal to 10 squared. So x is equal to 100 because 10 squared means 10 times 10, and 10 times 10 is 100. Now we're going to look at an example of an equation with a fraction inside of a square root symbol. Now I want to make point one thing out to you. X is already isolated here. We are not using inverse operations in this equation because x is already isolated. Instead, we just need to simplify this numeric expression. When a fraction is being square rooted, that fraction square rooted is equal to the numerator square rooted divided by the denominator square rooted. Remember, every square root without a context, meaning just in general, no word problem with it, is going to be positive or negative. So we have positive or negative. The square root of 49 is 7, and the square root of 100 is 10. So this equation is equal to positive 7/10 or negative 7/10. We can't tell which one because we're not looking at a context, a real world situation. Now, this fraction does not reduce, but when you solve yours, one of yours does reduce. So if it said x equals plus or minus 6/8, you would need to reduce that by 2 to get x equals plus or minus 3/4. So just kind of be looking for that if your fraction is one that would typically reduce. So let's look at an equation with a cube root equal to a positive number. Now, we're talking about a positive number because if you multiply a number 3 times in a row and end up with a positive, then that number had to have been positive, because a positive times a positive makes a positive, and a positive times a positive makes a positive. So if a cube is equal to a positive number, then this number has to be positive as well. The opposite is also true. If this would be a negative, then our number must be negative, because a negative times a negative times a negative is equal to a negative. A negative times a negative is a positive, and a positive times a negative is a negative. So we're going to need this kind of knowledge for the next two problems. So in this equation we see a cube. The opposite of a cube is a cube root. A cube and a cube root eliminate each other because they're inverse operations, isolating x for us. But if I cube root one side, in order to keep the equation equal on both sides, I need to cube root this side. So x is equal to the cubed root of 27, which means to multiply 3 times in a row to get 27. Well, 1 times 1 is 1, times 1 is 1. 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. So our x is equal to 3, and only positive 3, because positive times a positive times a positive makes a positive. Now let's look at an example when the cube root equals a negative value. And I forgot the... I think I missed one. Back up. Yeah, there it is. So let's look at the equation when a cube root is equal to a negative number. So you see that this really looks similar to the last one that we were looking at, except the cube is equal to a negative 27. So when we cube root each side and use the inverse operations, we are now looking for a number that can be multiplied 3 times by itself to get a negative 27. So we know that when this is negative, we'd have to multiply 3 times in a row. So negative 1 times negative 1 makes positive 1, times negative 1 makes negative 1. Negative 2 times negative 2 makes positive 4, times negative 2, which makes negative 8. Negative 3 times negative 3 makes positive 9, times negative 3 makes negative 27. So x is equal to the cube root of negative 27, which means x equals negative 3. Now let's look at an equation with a cubed root. This x is being cube rooted. The opposite of a cube root is 2 cubes. So I'm going to take this whole side and put it to the third power. The cube and the cube root will eliminate each other since they're inverse operations, leaving us with just x. Now x is isolated. If I cube this side, then I need to cube this side, which means I need to multiply 5 by itself 3 times in a row. 5 times 5 is 25, and 25 times 5 is 125. So x must be 125. So let's summarize what we've learned. When solving equations, use inverse operations to isolate the variable. And remember, every square root out of context has 2 answers, one positive and one negative.